In this video, we're going to talk about how to graph linear inequalities. So this first example here says to graph the inequality on the axis below. Y is less than 1/3 x minus 6. This looks very familiar to the lines we've been graphing all year. Usually it would say y is equal to 1/3 x minus 6. So to graph this, I would just go to the y-intercept of -6 and use a slope of 1/3, up 1 over 3, up 1 over 3, up 1 over 3, and then go this way, down 1 over 3, down 1 over 3, down 1 over 3. Those are all my points. I'm about to make the line, but this one's different. It says graph the inequality. This is not an equal sign. This is a less than. So what you need to know about graphing inequalities is that it works just like graphing lines with two differences. Then they're pretty major. If I ask you to graph a less than or a greater than, then you need to use a broken line. And sometimes you'll see it called a dashed line. And what that means is your line is going to look like that. And if your graph has a less than or equal to or a greater than sign, then it needs to be a solid line. And that would look like this, obviously. Let's put arrows on the end of those. So this one's just a plain old less than. So I need to make this a dashed line, a broken line. So I don't have a ruler. I'm just going to do my best to make it a straight dashed line here. Perfect. All right. Now, what a dashed line means, what a broken line is, that is a boundary that doesn't actually include any of the points on it. So all those points I just made are not actually solutions to this inequality. If I try to put 9, -3 into this inequality, I would get -3 is less than 1/3 of 9 minus 6. I would get -3 is less than 3 minus 6, which is -3 is less than -3. -3 is not less than -3. That's a false statement. So all these points lie on the boundary of all the possible solutions, but it doesn't actually include any of those points. So where are the solutions? Well, when you graph an inequality, besides making the line maybe dash, the other thing you have to do is you have to shade. You might shade above the dashed or solid line, and you might shade below the dashed or solid line. And that's all based on the inequality itself. This one says y is less than 1/3 x minus 6. So to determine which side to shade, all you do is pick a point somewhere on the coordinate plane that's not on the line itself. I'm going to pick 0, 0. And I'm going to put that in to this inequality and see what happens. So x is 0 and y is 0. So I'm going to get 0 is less than 1/3 times 0 minus 6. So 0 is less than 0 minus 6. 0 is less than -6. I plugged in the 0, 0 for x and y, and then I simplified, and I got 0 is less than -6. That's a false statement. That's a lie. 0 is not less than -6. So that means the 0, 0 and all the points on this side of the dashed line, those are not solutions. None of the points will work in this inequality. Nothing on this side should be considered a solution. Well, where are the solutions then? Well, the solutions are down below. If they're not above, they must be below. Let's double check that. Let's pick a point like -6, -9. Let's pick that point right there. Sorry, 6, -9. Let's see what happens. So let's do 6, -9, and let's plug it in here. We have -9 is less than 1/3 of 6 minus 6. So -9 is less than 2 minus 6. -9 is less than -4. That is a true statement. -9 is less than -4. So when I go to graph my inequality, make sure you determine whether the line is dashed or solid, and make sure you decide which side of the line is shaded. This point was successfully plugged in here and made a true statement. So I need to make sure that this side, every single possible point on this side, is considered as a solution. And to do that, we're going to do these stripes. And that makes it obvious to whoever's looking at this that this whole region is a set of solutions for this inequality. Let's do one more quick example. So this one has a similar setup, except it says we're solving a system of inequalities. We just did a problem very similar to this, but now we're doing a system of inequalities. The word system means that I'm giving you more than one inequality. So they want us to graph both of these at the same time on the axes. And then after we graph them, it says to state the coordinates of a point in the solution set. So in our first example, any point in the shaded region was in the solution set. But now that we have a system, any point shaded twice, any point in both lines, both inequalities solution set, would be considered a solution to the entire system. So when we're done, we're going to look for a point that's been shaded twice. So let's graph this one. Y is less than x minus 5. That one would be here, 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 here. I'm going to make all the points, make it easier for me to graph without a ruler. So let's do a dashed line. Not bad. And let's test 0, 0 and see if 0, 0 is a solution to this one. So 0 is less than 0 minus 5. 0 is less than negative 5. That is not true, so I should not shade towards the origin. 0 is not less than negative 5. So I'm going to shade this one this direction. Now let's graph this one. Y is less than or equal to negative 1/3 x minus 1. So let's go to our y-intercept, negative 1. And our slope is down 1 over 3. Negative 1/3. Down 1 over 3. Look, there's a point right there. Down 1 over 3. Down 1 over 3. Let's go the other way. Up 1 over 3. Up 1 over 3. Up 1 over 3. Now this one's less than or equal to. So this one needs to be a solid line. A completely solid line. There we go. And let's determine shading on this one. Let's try the point 0, 0 again. 0 is less than or equal to negative 1/3 times 0 minus 1. 0 is less than or equal to 0 minus 1. 0 is less than or equal to negative 1. That is also a false statement. So again, don't shade on the side of the origin for this line. Shade below it. Now when I shade multiples, I try to make sure the shading goes in opposite directions so that it's obvious where it's been shaded twice. All right, so what we have here is a graph that has been shaded twice. The question asks for the solution, one of the solutions from the solution set. So any point in this region that's been shaded twice could be considered here. Just make sure that you don't pick a point directly on this dashed line because none of those are actually solutions. So anything here would work. I'm going to pick 6, negative 6 as an answer that they're looking for. 6, negative 6 is a solution to the system. And just because I have an extra second here, let's plug that in to both and make sure it is indeed a solution to both of them. So if I put this one into the top one, we have negative 6 is less than 6 minus 5. Negative 6 is less than 1. That is true. Now let's put it in the other one. Negative 6 is less than or equal to negative 1/3 times 6 minus 1. Negative 6, negative 1/3 of 6 is negative 2. And negative 6 is less than or equal to negative 3. Negative 6 is smaller than or equal to negative 3. That's also true. So the point that I picked, which was shaded twice, is indeed a solution to both inequalities. So it's a solution to the system of inequalities.